What's next Wednesday? Ooh, on chapter 2, sections 2.1 to 2.4. So what have we better do today? Do 2.4. So that way this weekend you guys can go ahead and finish up 2.4 homework, maybe even start on the review. And come Tuesday to just need to talk about the things that we don't get and we want to rehash before Wednesday. Does that sound good? We don't have a Monday. I mean, you do have a Monday. You forgot? Oh, goodness. Yeah, you only have 3.5 days. Nope, 3 days to get through. And then a half day to survive and not complain to the ASB about how things are rigged. Anyway, senior shirt. It's good. Although you guys wouldn't complain because you're seniors, but it depends on how it goes. You might actually end up complaining. ASB people, just keep loving them, and ASB people stay strong because you're going to face the wrath of a lot of kids, and it's not your fault. So just hang in there. It'll be all right. Oh, on Spirit Day, though, it's a whole other level. Just hang in there, be strong. When Mr. Richmond says, watch out for me, I was actually pretty good last year, so. It's usually about him, not about you guys, but that's okay. We're just Senior Kendrick and I, so we have to be careful not to be disrespectful. What do you guys do for number 49? Plug in. Why'd you plug in? Limit? Continuous? Limit must exist. How does the limit exist? When the left and right agree. So therefore, 4 minus 1 quantity squared needs to equal a times -1. I apologize. Minus -1 squared. There we go. A times -1 squared minus 1. What do you guys end up getting? Good. Dun, 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 dun. Okay. Number 50, continuous function. Find a value a so that the function blah, blah, blah is continuous. What do you guys do for that one? Plug it in, right? And therefore, you should have ended up with a equals -1. Good. I know, right, it's right there. 58. I think there's like a piece of dirt or something. I don't know. Anyway, number 58. Which of the following statements about the function is not true? A. True or false?
True. False.
Good. Why is A not existing true? No, why is A... What am I trying to say? Yeah, it's the whole not thing that's throwing me off too. Is not true, aka false. Okay. Why does A, f of 1 is what I meant. Why does f of 1 existing prove it not true? Blah, blah, blah. Why does f of 1 exist? Yeah, as x approaches 1. So therefore, that's the not true one. So then why are these ones true? Because what if that was E? You would have had to gone all the way through the others. So the limit as x approaches 0 positive exists. Why? Which piece are you plugging into? First, second, or third? First, because greater than 0. So you could plug in, you would get an answer of 0, right? Letter C, what piece would you plug into to go towards 2 from below? The last one, good, plugging into. And it does exist because there's no problem plugging in. And then letter D, why does going to 1? The first one and the last one, why does the middle one not matter whatsoever? Yeah, that's the at. We're looking at the approach. So then plugging in 1, we get 2, and plugging in 1, we get 2, and 2 equals 2. Sweet. And then how about the bottom one? True, because they don't equal each other, because we just saw that the limit is 2 and the at is, and 2 does not equal 1. So which one's not true, aka false? If you guys see the not true or the not false, I've never seen that one, though. But anyway, false might be an easier way of looking at it. All right, we're okay, right? Piecewise functions, we getting better at them from the summer review packet? Okay. So then we're in section 2.4. Hold on, 2.3 is what we finished up yesterday, except for what? How was I supposed to finish this example at the very end of yesterday? Did we? We talked about it. I don't know if we actually did it, though. Oops, that's not what I wanted at all. Zoop, zoop, zoop. How would you see if IVT applies? Yeah. Because f of c equals k. Which k? Well, I just crossed it out. That one. Then 6 is equal to. And why did we figure out that it applied? Because f is continuous. What does the theorem say? Good. On the closed interval of 5/2 to 4, which is why the discontinuity at 1 doesn't make a difference. And so to solve, we would have gone ahead and, can we mental math it? We'd end up with 0 is equal to x squared minus, check me, 5x plus 6, right? So then my guaranteed c's, which are the same thing as my x values, right? If we had actually made it f of c, which I didn't, I was lazy. Why am I just going to say 3? 2 is not within the interval 5/2 to 4, so it is not one that is guaranteed by IVT. Doesn't mean it doesn't work, just not guaranteed by IVT. Only one guaranteed by IVT. 3. Does that make sense? Cool, let's go grade. No? Okay. Give an Isa a second. Hey, be nice. Oh no. No. Oh, sorry guys, I thought I had to answer. Oh, I do. Here they are. Section 2.3. All right, cool kids. What are my evens? 2? Perfect. Infinite discontinuities, otherwise known as vertical asymptotes at 1 and 3. Asymptotes. Infinite, or you could have also said non-removable discontinuities at 1 and 3, aka vertical asymptotes. What's something else? Oh, lo siento. Lo siento. The function is continuous for all real numbers except 1 and 3, where there are vertical asymptotes or non-removable discontinuities, or you could have called them infinite discontinuities. Is that good? Number 12, A is 1, B is 2. C is no, D is yes. Oh, sorry. No. Oh, sorry. Yes, no. My bad. I was just seeing what the answer was. Yes, no. Yes, no. 20. Discontinuity at x equals 2. It is a removable one. It's a piecewise function, and so the way to remove would be to change the second part, the second piece, to be 1 instead of 2. The weird thing about number 20 is since it's a piecewise function, you can't remove by reducing. You would have to redefine the piecewise function. But you could just redefine it. You could make it continuous by making f of 2, which is the at, right? When x equals 2, making it 1. Sorry, next one, 24? All points not in the domain, along with 1 and 2. And all points not in the domain, I mean, that's kind of just like an understood, right? Like we should know not in the domain, because we should know domains, but also not 1 or 2. And then letter B, 1 is not removable, aka non-removable, because there's a break. 2 is removable. It's a whole. It can be reassigned. Next one. Yeah. Same, we don't like it. Give a formula for the extended function that is continuous at the indicated point. Why is number 28, sine of 4x over x, why is it removable? Oh, not internet. Come on. Yeah, because it's 0 over 0. Good. So for number 20, What? Oh, well. Okay, sine of 4x over x. Because it's 0 over 0, keep going at 0, right? if we wanted to do an extended continuous or a continuous extension, sorry, is that what they're asking for?
Yeah.
An extended function, we could redefine the whole. So we could say that guy's totally good for everybody but 0, right? And we just need to redefine what's going on at 0. But to redefine in a way that we fill the hole, don't you have to figure out what the limit really is? Does that make sense? So we're filling the hole. And the limit as, I mean, if you guys would do this a few different ways, the final answer is going to be 4, but why? Yeah, you could do L'Hopital. That's one way. The derivative of 4x, because a 0 over 0 would be 4 cosine of 4x all over 1. Plug it in, 4. The old-fashioned way would have been the special trig limit. Sine of u over u. Oh no, I don't have 4x. Couldn't we multiply top and bottom by 4? That's the algebraic way. Special trig limit goes to 1. 1 times 4 is. So yeah, L'Hopital's or multiplying top and bottom by 4 and going from there. All right. No. You get 1 in the bottom. Sorry. Derivative the outside cosine, keep the inside. So 4 cosine 4x over 1. And then you plug in 0. Cosine of 0 is 1. 1 times 4 is 4. Yeah. Sorry, I didn't show my work. If any of you guys are not would that be auditory? Like if you need to see it, just raise a hand and be like, can you write that? And I can write it. I don't mind. I do a lot of stuff like just saying it. And I apologize if it's not keeping up or it's not letting you keep up. Okay, next one. Thanks, Sally. One possible answer. Good. What needs to be the same from the clues that they gave you? Thanks, Riley. That's perfect. Let me get some white space. Okay, what needs to be the same? Yeah, and did they tell you, like, does it have to be the whole and then the filled in from what they gave you? Okay, so yeah, it does need to be filled in from the branch that's above. But technically, I suppose you could have even had something like, oh, where are we going? Sorry, -2. There we go. Doesn't necessarily mean that that guy has to be on top. It just means that coming from above has to actually be going towards the point. And this broken, because it has to be broken for the limit not to exist, the broken piece has to have the whole. Yeah?
The filled in one has to come from the right?
Yes. And here's why. No, it's okay. It's because of the limit as x approaches, it said 2 from above has to equal f of -2. So it doesn't matter if you had a parabola, if you had a sine function, if you had a vertical asymptote thing for this part, but this branch, whatever he looked like, had to come in towards a filled-in point, and this would be somewhere else with a hole. Good. Is that okay? Yeah. Yeah, we can go back. Any other odds that we passed that you guys want us to go back to? Maybe. For right now, we'll just do 31. Okay. Number 31, we get some white space again. There's the answer. You guys can see the solution. But the problem itself was saying, explain why the given function is continuous. Is that 31?
Yeah, because normally like if I happen to see that it's like, this is f of c, then the equal, but like, how do you
Yeah. No, that's true, because it is confusing. They just said explain why the given function is continuous. If you guys noticed, because even number 32, right? Discontinuity at 1, number 31, discontinuity at 3. What they're asking for isn't real numbers. Are there any x values where the function is not continuous? It's saying, why is the function continuous in its domain? Does that make sense? Is 1 over x minus 3 a continuous function? Yeah, everywhere in its domain. So it was one of those, it was asking you to dig a little deeper. It's totally fine that you guys figured out there's a discontinuity at 3. That's true. It wasn't asking you to compare it with every other function, aka compare it with all real numbers. It was asking you to compare it with itself. and ask, knowing that the domain, does that make sense? Knowing that the domain is x can't be 3, is it fine everywhere else? So in the description for basically describe the continuity, yeah, it's continuous for all points in its domain, aka for all points x not equal to 3. I think that was technically in what we covered yesterday in that weird, like, continuous on a closed interval. There we go. That we can say a continuous function is a function continuous everywhere in its domain. So it's a struggle because they just said this, assuming that you would think that. But we're so used to AP questions where they're asking for discontinuities and they're assuming that we don't know without doing work. Like, they're assuming it's not just second nature. Of course it's continuous everywhere but the domain. So in AP questions, you have to watch out for if it says something like, is it continuous for all real numbers? That's when you would need to state the discontinuity with the domain problems. Does that make sense? All right. Yeah. Yeah.
Because, like, if you're just saying, like, aside from the domain problems, like, isn't that just your function, aside from everything?
Oh, what it's saying is like to use the definition I just showed you in the notes. Right. Since the domain is x does not equal 3, but that's the only place where there is a discontinuity, then thus the function can be called continuous because it's continuous everywhere but everywhere within. So it's basically just having you struggle with the technical definition of a continuous function. Does that make sense? Okay. Yeah. No. It is a really confusing question. I agree. That's why I gave you guys one of those. Did I give you both or just one? Just one. Okay. We were down at number, I don't know, 42. What's next? It's right here. They gave a lot of sense. They were saying the limit from below, I think it's a piecewise, right? The limit from below, it must have been less than or equal to. So f of 2 is the limit from above, is 7. Limit from above, plugging in would be 2a plus 1, so then a is 3. Yeah, it's like the ones that we just did a second ago. Anything else? Yeah. Any other evens, or are we done with evens? Okay. So going back to 12C, then if you guys have any other questions, have it ready. 12 was asking us for, given the graph, does the limit as x approach 1 of f of x equal f of 1? Okay, just thinking about the statement, like not even worrying so much about the graph itself. Does the limit as x approach 1 of f of x, you could say something like, just putting it in words, does f of x's two-sided approaches towards x equals 1 agree with the point at 1? So do the two-sided approaches agree with the point at 1? And looking at the graph towards 1, or around 1, I should say, I see something like, hey, coming from either side of x equals 1, they're in agreement as to where the two branches are approaching. But the problem is, what's going on at 1 itself? The point is somewhere totally removed. So the reason why it's no or false, I think it wasn't a statement, I think it was a question. So no is because what's going on as the graph approaches x equals 1 disagrees with f of 1. Remember, this is just talking about the y value when x is equal to 1. Does that make sense? Yeah. It's all that function notation of f of x such that or when. Remembering that those are the y values, and then that was just telling us where to look. So, yeah, they don't agree. That's why it's no. Anything else? Odds or evens? Going. Gone. All right, here we go, section 2.4, tangent lines and sensitivity. Tangent lines? What? That was summer review stuff, wasn't it? We need a derivative. We need a point slope. Let me get rid of that, who randomly opened. Why do I have secant line underneath average and tangent line underneath instantaneous? Remind me of how we find the slope of a secant line. Taking 2 points. Good. And specifically taking 2 points, we can think about between time b and time a, the change in the function. Same thing as y2 minus y1 over x2 minus x1, but in a little bit better context of what we saw with motion. Nice thing is pre-cal and CalcAB both talk about average rate corresponding with slope. F of b minus f of a all over b minus a. Slope of a secant line, no stress. You have 2 points. Plug it in, average rate. Average rate. Instantaneous rate. I need a slope at an instant. And the only way to find a slope at an instant is to make the delta x, the change between 2 points, approach 0 of an average rate formula or of a slope formula. And that's only possible using limits. And the shortcut to that, or the definition that that points to, is, yeah, just the derivative. Which is why the bottom is saying, hey, let's remind ourselves of all the different ways of talking about a derivative. We could talk about a derivative as being the slope at an x. Ooh, I have the wrong light turned on. Let's turn off both. We can talk about a derivative as being a slope at 1 point and 1 point only. We can talk about a derivative as being the slope of the tangent. We can talk about it being the instantaneous rate. What you guys see, hopefully, over and over and over again, if it was in words, would be at, not. What would it be for secant? They don't use the word at, they use the word. I guess there's 2 ways. It could say in between. They're probably not going to say that, though. It'd probably either be from and to, right? Or the word over, like over the interval. Number 4 is just a variation. But I'm wondering if on 4 and 5, if you guys can tell me, because this one up here is just f prime of x, right? But how would we simplify 4 and 5? It's not f prime of x. Huh? Yeah, but you don't necessarily need to write it like word for word. It can be slope at, slope of tangent at, instantaneous rate at, or just the rate at. But I do want you guys to write down, because those are the ones that just tend to trip us up when we see them. We tend to think we have to solve it the long way when we could really just do it the easy shortcut way if only we could tell that they're really talking about if only we could tell what they're really talking about. Derivatives, good. General derivatives or specific? Specific. And specific to or specific at? All of these are the same. So where are these pointing? Where are all of them pointing? Explicit derivative at a, right? Whether it says the slope at a, whether it says the tangent line at a, slope of the tangent line, whether it says the rate at a, whether it says the limit as h approaches 0 of f of a plus h minus f of a all over h, or the limit as x goes to a of f of x minus f of a all over x minus a. Each and every one of them are all pointing to the same, oh, just find f prime of a. 1, 2, and 3, they tell you f. Sweet, use it, derive it, plug in a. 4 and 5, f is hidden. Four and 5, f is hidden. So you have to determine, in order to find f prime of a, you'd have to remember that. To find f prime of a, first we have to determine who is f of x, take the derivative of f of x, and then plug in a. And that's the dilemma with just a few of you guys on how to solve 4 and 5 using what it actually defines. You have to find out who f of x is first and then plug in a. So all stuff that we've seen. 4 and 5 is the trickiest way they could give it to us. Without saying something like how fast in some sort of motion problem. Without saying something like how fast in some sort of motion problem. Oh, you guys can't read that, probably, huh? Using an at and not an over. I thought these were interesting. It's kind of random, except they're actually in this section of notes in your textbook. Textbook, those are things we're supposed to learn from? Yes. You don't need to write this down. It's not something I'm going to test you on. It's not something that I'm going to require you to regurgitate or do a report on or do a presentation, although that should probably be somewhat part of this course. However, there is this whole history behind everything that we're doing. And so maybe on Monday just a little bit, Tuesday just a little bit, since we do have a review, we might come back and talk about this. I thought it was kind of interesting as to where the word normal comes from, meaning perpendicular. And talking a little bit about Fermat and where he came from. But anyway, we're going to move on for right now because there is a second big part too. Look, it's a nice short section. That's why I thought we could finish it today, even though we only have 5 minutes left. Let's talk about sensitivity for just a second. Sensitivity. Super interesting application of calculus. Not that there are nurses or doctors that are necessarily using calculus to do this. Every time they're doing some sort of prescription. However, it does make you realize that there is a lot more behind how much medicine a person should receive. Beyond just what's ailing them and how to treat those symptoms. Maybe we're just briefly touching on anesthesiologists and why their jobs are so complicated. Well, and high pressure. Does anybody know why anesthesiologists, why it's one of the highest paying and yet the most risky jobs? Lawsuits, yeah. But why is it so bad? No big deal. Someone has a fever, give them Tylenol. Now, that's this, right? Anesthesiologist is during an operation, all that. But why is it weird? But why is the dosing so hard? It's based on so many different things, right? It's based on the patient's age and the patient's body size and the patient's medical history. So many different extenuating circumstances or causes, and they need to be kept within a certain safe range, right? You don't want them too alert, you don't want them too far gone. Okay, anyway, so there's sensitivities to medicine that need to be considered. Now, we're not going necessarily into the whole anesthesiologist thing too much, but that does kind of at least give you a bit of a peek into why this is even a thing. And sensitivity isn't just a thing in medicine. It's really not, but that's the example that we're using. So how one variable responds to small changes, infinitesimal changes. Anyway, sensitivity. As you guys look at this example down below, I think most of you have the beginning part up above. I mean, sensitivity, we could do this whole life lesson about sensitivity, but for right now, sensitivity is good, but then too much of it can be bad, right? We all know that just based on friendship, relationships, etc. What's going on? If I were you, I would definitely write down this information because this is what we need as we go into this problem down below. Sensitivity can be defined to be the limit as delta D goes to 0 of change in T over change in D. Another way of saying it is that delta T can be sensitivity times delta D. Wait, what are all these things? Well, let's look at the example. A patient enters the hospital with a temperature of 102. Is given medicine to lower the temperature. As a function of the dosage, what's D? Dosage. Measured in milligrams, the patient's temperature will be T. Oh, so what's T? Temperature. Good. So we have temperature and we have dosage. So temperature as a function of dosage is equal to 99 plus 301 plus D. Milligrams. Find and interpret the sensitivity of the patient's temperature to the medicine dosage when D is equal to 1 milligram. Sensitivity. So what are we supposed to be finding? Well, guys, I'm going to scroll up just a little bit. I apologize, but how could we redefine sensitivity knowing our calculus knowledge? It's talking about small changes in dosage and how it affects temperature. Cool, but what is this? It's a definition of derivative. These are my x's, those are my y's. Limit as delta x goes to 0 of delta y over delta x. Isn't that just f prime? But wait, who's the prime in this guy? Who's my y? So I'm finding t prime at d. Really? Yeah. So to find the sensitivity, all we have to do is take the derivative of this dude and plug in 1. So, oh no. Okay, I'm just kidding. Be respectful of authorities.
Just a quick announcement for all freshmen and girls. This year we are starting a mentorship ministry called Priceless, where you will be given the opportunity to be led and build relationships with some of our senior girls. For more information and to meet your mentors, come to room 112 today at lunch and sign up to be placed in a small group. Thank you.
That was cute. Do you guys agree with negative 3/4? What are my units? So is it possible that sensitivities will change based on the dosage of the medicine? So if the dosage is 1 milligram, then the temperature is going to go down 3/4 degrees. Oh yeah, it's supposed to be bringing down the temperature for every milligram that, but then it's going to be constantly changing. Well, this is more complicated than we thought. Anyway, it's really just a derivative. It's really just an application, but it's cool because you're going to see just a little peek into some further application of some of what you've learned. I'll see you guys later. Get out of here. Homework number 6, 2.4 due on Tuesday. That's the end of the section. We got there. Good job, guys.